Okay, let's talk about uranium. Yes, the element they put in bombs. So let's get started with the question that we're all the most excited for. How does uranium, explode? Let's start simple. Look at the nearest object under an atomic force microscope, and you won't be surprised to see that it's entirely made up of atoms. In the core of each atom is a nucleus, and if you were to split it in half or combine two together, yeah. But why does this happen? You see, during nuclear fission, the nuclei, that's plural for nucleus by the way, split into smaller, less heavy atoms. But during the process, tons of energy is released, even more depending on how heavy the atom is. And it just so happens that uranium is very, very, very heavy. This would create a shock wave powerful enough to knock over cities easily, a weapon of mass destruction known as the atomic bomb. But you and I both know that's not near as powerful as we want. So what do? We take everything we just talked about and scale it up by a lot. Introducing the hydrogen bomb. But before you can see just how powerful it is, we first need to know how it works. The process of the hydrogen bomb is split up into two main stages. Stage 1. Nuclear fission. Nuclear fission is the process in which a smaller set of explosion triggers a chain reaction that splits the atoms of uranium. Stage 2. Nuclear fusion. Now, although sounding similar to fission, fusion is the exact opposite. You see, during fusion, the bomb generates energy by fusing two different isotopes, deuterium and tritium. But after fusing, they split again with fission. This repeats hundreds of times in the course of a millisecond, until enough energy releases and the whole thing explodes. But what if I told you we could go one step further? Introducing the Tsar Bomba, with shockwaves traveling over 500 miles, and here's how it's made. FBI, open up! Never mind.